Good morning, student. Today we are going to learn about vocoder. After the completion of today's session, you are able to define vocoder and describe the operation of vocoder. So, vocoder is an audio processor that is used to transmit speech or voice signal in the form of digital data. The full form of vocoder is voice coder. Vocoders are used for digital coding of speech and voice simulation. Vocoder operates on the principle of formants. So, what is formants? Formants are the meaningful components of a speech that is generated due to the human voice. Okay, means that information a person is giving by their speech. From that speech, the meaningful components of that speech is known as formants. Okay, whenever a speech signal is transmitted, it is not needed to transmit the precise waveform. We can simply transmit the information by which one can reconstruct that particular waveform. Vocoders are used for voice synthesis. The vocoder takes two signals at its input and creates a third signal using the spectral information of these two input signals. Okay. Next is the voice model. A voice model is used to simulate voice. Okay. As speech contains a sequence of voiced and unvoiced sound. So, what is that voiced and unvoiced sound? Voice sounds are the sounds generated by vibrations of the vocal cord, and the unvoiced sounds are generated by expelling air through lips and teeth. Everyone knows that during any type of conversation we face all these things. Okay, so we can distinguish between that voice sounds and unvoiced sound. Voiced sounds are simulated by the impulse generator, the frequency of which is equal to the fundamental frequency of vocal cord. Means according to the frequency of our vocal cord, the frequency is similar with the impulse generator frequency. Then the noise source present in the circuit, this one, is used to simulate the unvoiced sounds. The position of the switch helps in determining whether the sound is voiced or unvoiced. Okay, this switch determines that. Then the selected signal is passed through a filter that simulates the effect of mouth, throat and nasal passage of speaker. The filter unit then filters the input in such a way so that the required letter is pronounced. Okay, this filter helps. So, LPC is extensively used in case of speech and music application. So, what is that LPC? The full form of LPC is linear predictive coding. This technique is used to predict the estimate future values. So, we can say by analyzing two previous samples, it predicts the outcome. So, the vocoder is comprised of voice encoder and decoder. So this one is the theory that we already discussed. Then first one is voice encoder. The frequency spectrum of the speech signal is divided into 15 frequency ranges by using 15 bandpass filter, each having bandwidth range of 200 Hz. So here the frequency spectrum divided into 15 frequency ranges having bandwidth 200 Hz, each bandpass bandwidth. So 200 to 400, like this 15 frequency ranges present here. Here in the last you can see it has written 3200 to 3200, so it is actually 3000 to 3200. Okay. Then the output of bandpass filter acts as input for the rectifier units. The signal is rectified and filtered so as to produce a DC voltage. As we know, the rectifier converts the AC signal to DC, and at the output we never get a pure DC. Because of that, we always use filter circuit at the output of the rectifier. This generated DC voltage is proportional to the amplitude of AC signal present at the output of the filters. So the input to the frequency discriminator, this one, is the speech signal. Frequency discriminator unit is followed by a low pass filter of 20 Hz. This low pass filter generates a DC voltage proportional to the voice frequency. The output at all the LPFs, means the output of low pass filters, generates a DC voltage which is sampled, multiplexed and analog to digitally converted. Means this part, using this part, it converted from analog to digital, sampled, multiplexed, all functions are performed by this block. So we have a digital equivalent of the speech signal at the output of the encoder. Okay. This encoded voice signal consists of frequency component from 200 Hz to 3200 Hz. Next is the voice decoder. The demultiplexer and DAC section convert the received encoded signal back to its analog form. Means this block performs the reverse operation of this block. Okay. The functions of this block, what are the functions? Multiplexing, analog to digitally conversion, these are the function of this block, and this block perform exactly the reverse operation of the previous block present in the transmitter section, means encoder section. So here a balanced modulator filter combination is used in correspondence to rectifier filter combination at the encoder. Okay, this one. The carrier to this balance modulator is either the output of noise generator or pulse generator. Here you can see, to this balance modulator, from this switch we give input to the balance modulator, and this switch is controlled by this decoder. Okay, So, but this depends on the position of this switch. Okay. The switch position is decided by the decoder, because when the voice signal is received, the switch connects the pulse generator. Okay, the switch connects the pulse generator. When an unvoiced signal is received, the switch connects noise generator output to the input of all balance modulators. Means this one connect with this noise generator. So as per the signal received, that may be voiced or unvoiced, decoder decides that and connect this switch accordingly with the pulse generator or with the noise generator. Okay, the adder will thus add up all the analog signal and produce voice or speech output. This adder. Speech transmission using vocoder is helpful technique, but it has a disadvantage. This is because it leads to degradation in speech quality. Okay, this is all about vocoder. Thank you.